Hello, fellow game makers. Episode 2. And today it's gonna be all about clamping the player's movements so they stay inside the bullet board because, as you can see right now, we can move whatever the hell we want. And we don't want that in our game. So, I already apologize for not posting yesterday. I was busy with my own project, making sure the mobile inputs were working correctly and I lost track of time. So we're gonna record today. So if you came from Filipino L's channel, check out her channel by the way, she's doing an amazing series. You're probably thinking that we're gonna do some collision checking with functions like place meeting or position meeting. And that's not what we're going to do. And the reason we're not going to do that is because collision checking in Game Maker works based on our collision mask. And the bullet board has a collision mask which covers the entire sprite, including the middle. So if we, for example, set our X speed and Y speed to 0, if we have a collision with the bullet board, we wouldn't be able to move at all because it's always detecting a collision. So what are we going to do instead? We're going to be manually clamping the player's X and Y so it can never leave the bullet board. And to do that, it's going to be pretty simple. So in our step event for the bullet board, let's set this. If instance exists also. It could be obj so in your project, but what we're basically doing here is we're checking if an instance of the so object exists before we run the entire code. And that's important because if there isn't an instance and we're trying to access variables from it and as such, it's gonna throw an error and crash our game. So, first thing we do with Oh, and the way the with statement works is that whatever we write inside these curly brackets is going to be executed as if it were running inside the also object. So if I were to write, say, for example, x equals 100, it's going to set the x position of also to 100. So how do we clamp the positions? Well, it's simple. We use the clamp function. We're going to say x equals clamp x, which is the variable we're trying to clamp, other dot bbox left, and two new things here. The keyword other in this case refers to the instance, as you can see in the screen that just showed up, the instance that's executing the with statement, in this case the bullet board. And bbox left refers to the leftmost position of our collision mask, right here. So we're basically putting our minimum value as the rightmost edge of our collision box plus 5. And 5 is the size of the border that I put for my own bullet board. Yours could be 6 or 4 or whatever. And we're going to be using that in the future, so we might as well save it in a variable here in the create event. Let's say border equals 5. Now we come back here, plus other dot border plus sprite x offset. And sprite x offset is a variable that determines the amount in pixels from here, our origin point, to the rightmost edge or the leftmost edge of our sprite. And the reason we're doing that is because unless you're putting the collision mask of your so object to be like this, bbox left is going to return where around here where I put my on. And you don't want to do that. You don't want a bullet to hit here and end up dealing damage anyways. That's ridiculous. Don't do that in your own game. So we're going to be using sprite offset plus sprite set. And that's our minimum value. Let's set up our maximum. Order.bbox, right? Minus, because we want to push the player a little to the left, order.border minus right x offset, right? And then we can just copy paste this and substitute every x for a y. Right, so my apologies, it wasn't about just setting every x to a y. We also gotta set our where we would have a b box left to our b box top, use sprite y offset, and here b box bottom. Okay, so if we run the game right now, you're gonna see that we can stay inside the bullet board, but there's a problem because we can move 1 pixel to the right or left or whatever position we're moving, and then when we let the key go, we get reset to the position we're supposed to be. And that happens because both step events for the also and the O bullet board are happening at the same time. So what's happening is that our movement code for also is running at the same time that our clamping code is running. So we're allowed to move 1 pixel to the left and then we get our movement clamped. So an easy way to fix that is just to take all this, Control X to cut it out, add a new event, the end step event, and paste it here. And if we move back over here, you're going to see that we have three events in the step event category: the normal step, the begin step, and the end step. And it's just as intuitive as it seems. The begin step happens first, then the step, then the end step. So what we're doing here is we're ensuring that our clamping code happens after every other code in the step event runs. And since we're running movement code in the normal step event, it's gonna be clamped F. The movement is gonna be clamped. Okay, sorry. And since we're running our movement code for also in the step event, we're gonna make sure that that happens first, and then we're going to clamp our movement. So if we run the game right now, it works perfectly. And of course, you're gonna have to trust that I am actually pressing the keys and that I'm not a master that releases the keys at the exact same time that I hit an outermost edge. Okay, so that's basically it for this video. I know, kind of a shorter one, that's sad, but in our next episode, we're going to be dealing with text, including typewriter, sound, pausing at commas and dots, so that's cool. I promise you're going to enjoy it. So thank you for watching. Make sure to leave a like if you liked it, and leave a comment if you have any questions or need any clarifications. So see ya.